Hello, I'm Eleanor Jones. I'm a Senior Teaching Fellow in Statistical Science at University College London, and I also chair the RSS Special Interest Group in Teaching Statistics. So today I'm going to talk about active learning for undergraduate statisticians. Now, just in case you've not come across active learning before, this is a definition that I really like. But in a nutshell, what we're talking about here is getting students doing stuff rather than learning passively. So the doing stuff could be things like, for example, reading, writing, discussing, problem solving, anything that means that they are not just passive recipients of the information. So there's a lot of evidence out there to suggest that active learning is really beneficial for students. Yes, in terms of their learning, but also in terms of other things as well. And I've been trying to implement this into my teaching for the last few years. And what I've noticed is, for sure, students better understand the concepts that I'm trying to teach them. But it's also really nice to see that students seem to be more motivated to learn as well. And it's great to see them developing some other skills, some of the softer skills, the communication, the teamwork, and especially the independence of thought. So things didn't quite go to plan this year, and this wasn't the talk that I thought I would be giving. So what I was going to do was to give practical tips on active learning strategies for undergraduate statisticians in large lectures. Now, of course, the vast majority of us, if not all, won't be giving large lectures next year. So instead of doing that, I'm instead going to be talking about, again, active learning strategies, but this time in online learning. So when I'm thinking about online learning, I'm thinking about the live or the synchronous sessions, but I'm also thinking about what happens outside of those synchronous sessions, i.e. the asynchronous activities. So in my opinion, anyway, there are two broad strands to what makes successful online learning and therefore successful active learning online. So on the one hand, we've got the teaching and the presenting of the material and making sure that we are balancing the live and the asynchronous activities and making any resources and activities available to students, make sure that they are varied and interesting and keep students engaged. And because my emphasis is on active learning, I want to make sure that as much as possible of those activities are going to be minimizing passive learning. But there's also the flip side to that. And because we're not doing face-to-face teaching, it's really important that we start to think about building a community. And that is for sure building a community peer-to-peer, so students can interact with each other, because there is a danger of them feeling very isolated while learning. But also because I'm not going to be physically present with them at any point, then it's also really important to think about meaningful connections with the tutors. And I'm going to concentrate on the teaching and presenting the material actively, but I'm also going to talk a little bit about building a community, that peer-to-peer interaction, because that also, in my case anyway, feeds into how we teach and present the course material and getting students to support each other in doing that. So I have a couple of modules in this academic year. They're both big modules. They have roughly 200 students each on them. And because we are moving online, I'm going to be taking this opportunity to try something I haven't done before with my teaching. And I'm going to be teaching everything in the sort of flipped classroom format. So if you've not come across that format before, what it means is that students learn all the material in their own time. So rather than giving them everything at once, I'll be chunking it up into sort of week-long bite-sized pieces. So students then get a certain amount of time to go through the material I give them. And again, I'm emphasizing that I'm going to be trying to get them to not to be learning passively, so getting them to do stuff while learning the material. I want the material and the resources to be as varied as possible. And I want to build in some asynchronous peer-to-peer support as well for the students. Now, because I don't want them just to be learning passively, What that means is that I'm not going to be presenting all of my material via pre-recorded videos. So I'm going to talk a little bit about what I'm going to replace some of those videos with. Now, those are the asynchronous stuff, but of course, there will also be some live sessions. And these live sessions are only there to consolidate learning. So they are there for students to practice applying the skills or the knowledge they should have learnt during the asynchronous parts. And they're also there because I want students to both interact with me, but I want them to interact with each other. And I'm sure that many of us over this lockdown period have experienced sort of Zoom fatigue, and I'm very aware that students will too. So I'm going to be keeping these sessions just to one a week, and they're going to be short, so no more than an hour each. It does mean, though, that I'm going to need to keep this in check, as there's going to be minimal tutor monologue and to try and maximise the time that students can work together. I'm going to talk a little bit about videos, even though I've just said that videos are a rather passive way of learning, because I will be using videos. I can't make absolutely all the course material in a sort of active learning style, so I will be using some videos alongside more active things. And it might be tempting to record entire lectures or even use recordings that you have from previous years. But videos really don't go down long videos don't go down very well with students. So at UCL, we record lectures anyway, as a matter of course. So I know that students have been watching these previous recorded lectures at sort of up to twice the intended speed, which can't be good for learning. And it's really passive. I don't want students just to be sitting there watching a video for hours on end. So I am going to be using a few videos. So the way I'm going to be doing them is very, very short videos. So no more than 15 minutes in length. But of course, thinking about, a 30-hour lecture course, that's a lot of videos if I decided to do all the course material in that way. I'm going to be recording myself as well as my slides because I think it's more engaging for students to see the person that's presenting to them rather than just hearing their voice. And I'm also going to be experimenting with embedding some interactivity inside the video. So there is software out there that means that you can do quite neat little things like embed quizzes inside your videos just to keep students engaged. So it's worth having a chat with your IT team to see whether you have access to that sort of software. But most importantly, I'm going to be interspersing any video that I do with other consolidating non-passive activity. So I've got 4 suggestions here of the sorts of things that are a little bit more active for students to do. They range from the simplest things to implement through to the more time-consuming strategies. So yes, we can get students to read. That's probably the most obvious thing we can get them to do. And it is less passive than just watching a video. But if you're getting students to read long passages, it will get a little bit dull for them eventually. So it needs to be broken up with some structured activity, which I'll talk about on the next slide. Now, one thing I really like to do with my students is a treasure hunt for information. So you could restrict them to only looking at the material that you're providing to them. But the way I like to do it is that I allow them to use any resources that they like. So I give them a particular topic. I give them a set amount of time. They go off, they research it, and they give me something in return. So it's usually some sort of document that they have to write in return. And students really, really enjoy that freedom to learn about a topic the way that they want to learn about it. Something else that's very popular with students is this idea of guided exercises or guided simulations. So if, for example, you have a very mathematical module, you might be presenting proofs. And it's very easy for students to read through a proof and think, yeah, I understand, no problem, move on to the next thing. But what I like to do with students is to take chunks of the proof out. So they have to think about the sort of connecting bits of the proof in order to be able to see the proof from the start to the end. So getting them to think about these things rather than just presenting everything on a plate is really, really helpful. You could do the same, switching out a proof for example, a simulation. So if you're looking at a topic that's, something very basic like central limit theorem, for example, get students to do some simulations themselves. So guide them through how you might do a simulation study so that they can see the results in action themselves, rather than just reading about it or even just sort of playing around with an app. I think there is value in getting the students to actually conduct those simulations, maybe in R themselves. So the final thing that I'm not really going to talk much about, but of course, you can create these interactive workbooks, for example, using our Markdown, which combines all sorts of things like embedded videos, some reading, and lots of interactivity, which is great if you have the time to create those sorts of things for your modules. But there are other things that you can do to break up some of the more passive elements of learning. So what's really important is that in an online environment, we need to be keeping track of what students are actually doing. Are they doing the work? So it's important to give them an opportunity to demonstrate their learning. So I'm really hoping that this motivates the students to do the original learning. And in an ideal world, it would also be something that is able to provide feedback for the students. Now, it could be individualized feedback, it could be general feedback, it could even be automated feedback. And these sorts of activities help me to monitor how the students are engaging with the material and how they're getting on with it. Are they coping with it? So some examples of the sorts of things that you might be able to do. So probably you're already asking students to do some exercise and submit them. Now, in terms of giving feedback on those, it's really important if students are submitting something that they feel they're getting something in return for that. So unless you've got an army of tutors to do the marking, that might get a little bit time consuming. But you could swap out the exercises for doing something else. So I get students to write maybe a blog about what they've been learning about. You could ask them to produce revision guides for certain topics. That's really popular because a lot of them like to write revision notes anyway, so they feel they're really getting value for money there. And something else that really appeals, especially to very creative students, is the idea of getting them to draw course maps. So you have lots of ideas and concepts during your module, and the idea is to map these out and, most importantly, to make the connections between the different topics, the different concepts that you're covering. Now, again, if they're submitting something like that, they're going to expect something in return. So I will spend a little bit of time shortly talking about how they can get feedback on that without burdening the course tutor. Something very, very easy to set up are quizzes, which can be done asynchronously, and they're self-marking. So that's great for students. They get to do something. You get to monitor how well they're getting on with the material, and they get immediate feedback. But something else that I used to do during lectures was to do this idea of minute papers. So get students to think about what it is that they're struggling with. What is it that they're not quite understanding at the moment? So if you're in a lecture situation, you might give them 1 minute at the end of the lecture to write down the 3 things that they found most difficult today. You can translate that very easily into an online thing where you, again, enforcing students to actually submit. You can get them to submit questions to a forum or perhaps to an upcoming live Q&A. Now, by doing that, the sorts of feedback that students would get in return might not be individual, but it's at least they could be getting something. So likely is that you will be getting students asking the same question over and over. So you can then intervene and they can see that you've taken that on board and you are trying to help them in resolving those issues. Now, those were more individual type activities, but we also need to think about asynchronous activities that actually connect students. And this is really helpful if you have lots of different time zones. So I know that my students are going to be all over the world, so there's going to be issues with time zones, and I want them to be connected with each other despite being up at different times. one of the things that I do that I'm going to be carrying on this year with is a student-led forum. So this is a forum for students to ask questions, but I don't answer them. So they ask questions of the course material, and the onus is on other students to answer each other. And this takes a little bit of getting used to. I have done slightly sneaky things in the past to get the ball rolling. I've logged in as a student and posted a question, or maybe even posted an answer, just so students don't feel that they're the first one to do it. But give it some time, and students get the hang of it in no time. The only time that I would intervene is if a question is too complex and no student can answer it, or that I feel that a student response to a question isn't quite hitting the mark and I need just to add a little bit of detail. You can set up asynchronous games such as quizzes with leaderboards. Students love a leaderboard, or mine do at least, so this is very popular. And you could also think about setting up collaborative spaces for students to work on documents together. So this in particular, if we think about the exercises, or maybe the write your own type activities, you can get them to do it in groups instead. So there's lots and lots of software you can use where students can collaborate on documents. But what I really want to talk about is the idea of peer marking, peer feedback. So when students submit written work, that they can actually get individualized feedback without you spending a lot of time looking through each and every student's submission. So the way this works is that students submit the task, the work that you've asked them to do, to whatever platform that you're using, and then you can allocate each submitted piece of work anonymously to another student. So this is going to be the marker. And a little tip, having done this several times myself, make sure that each piece of submitted work doesn't just go to one other student, it goes to at least 2 other students. Now, students receive those, their peers' work. They also receive extensive guidelines from me. It might be a marking scheme if that's relevant. It might be marking guidelines. And with those, they then mark the submissions. But most importantly, they also have to provide feedback. So this is really good if you've got a very big class and you can't personally provide weekly feedback for all your students. Again, a little tip, students need extensive guidance on how to give feedback. So it's a good idea to set up a live session where you talk through how to give feedback, or provide some sort of resource for them. Now, you could stop there if you like, but I found it's far more successful if you sort of do the next step as well. So each student receives at least 2 pieces of feedback on their work. And what I then get students to do is to reflect on that feedback and then to give feedback to the marker on how useful that feedback was. So what I'm hoping is happening there is students actually reflect on the feedback rather than just ignoring it. And I hope it also motivates the marker to actually give good feedback. So without this, what I tend to find is that the markers don't tend to give very much feedback at all. So those were some of my favourite ideas in terms of asynchronous learning and asynchronous activities, but there will be some live sessions that I'll be doing as well. And as I said earlier, I won't be teaching any material during these live sessions. So the sorts of things that I will be doing are sort of tutorial or problem classes, live Q&A sessions where I'm asking students, all students, to submit a question before the session, challenge sessions, which I'm going to talk a bit in detail about in a minute, and also some live practical sessions, because one of the courses that I teach is a linear models course. So I really like this picture, so I thought I'd talk a little bit about it here. So this was taken nearly 2 years ago now. I did get permission from the students to take the photo and to show it, but it shows a typical lecture. So there's very little of me lecturing to the students, and there's a lot of emphasis on student-to-student interaction. So I've set them a task in this particular case, and they're working through the task. And I want to recreate that sort of sense of community among the students in these online live sessions. So some things that you could potentially think about is to create teams at the start of terms. So it could be that this team stays together for the rest of the term. It could be that each time you have a live session, they randomize into a different team. You could, I think it's probably easier to randomize students to teams rather than to let them choose it, but that's also an option. And when they form these teams, there's got to be something for them to do, something very structured and very specific, which has an end goal. And the end goal is that they've got to submit some piece of work. I'm going to be using breakout rooms, virtual breakout rooms in order to facilitate this. So one of the things I'm going to be doing is this idea, but the idea that they perform challenges, or they sort of solve challenges during these live sessions. So I randomize my students to a group. It's a different group each week. They go into a breakout room and I give them a challenge. So it could be, for example, an old exam question that I know that students have really struggled with in the past. And they can use functions like the shared whiteboard, share their screens, etc., to work together on this particular task. I also have tutors that will drop in randomly to check that they're actually doing the work, but also to help them if they're finding it a little bit difficult. So not only do they have to solve it, they know they have to submit a piece of work at the end. So for example, if I'm giving them an old exam question, I'm asking them to submit their solution for that. And they have also been warned that there's an emphasis on how they present their solution. It's not just the content of their solution. So they submit their work, and in doing so, they give me permission to use their work if I think their solution is the best solution. So what happens then is I look through all the submissions, which actually doesn't take all that long because these are very short periods of time. So you're not asking them to do a very big question. And what I do is two things. I choose the best solution, but I also use the opportunity to collate some feedback on their work. So it's actually a really good opportunity for me to understand what the common misconceptions are, etc. And I put those together for students. So then I go ahead and I publish both the sort of model solution that one of the groups has come up with, plus my general feedback. So I hope that from talking to students, having done this as a sort of face-to-face activity with students, they definitely benefit from the peer learning. You can hear, especially when you're in a classroom environment, you can hear them trying to explain to each other different concepts that they need in order to solve the question. They also benefit, I hope, from my general feedback. And they also get a student-generated model answer. And this is really quick and easy to implement. It takes a little bit of time for students to get the hang of it. So you do expect a little bit of resistance to begin with, but they soon get into the swing of it. So finally, just a little bit on teacher-student interaction during these live sessions. So lots of students, well, most students actually, they don't want to stand out. They don't want to ask a question. So some of the other strategies you can use when you're trying to interact with the students yourself, polling, quizzes, voting, questions via chat so that they can post questions anonymously during the session. And what I really like to do right at the end of the session is to give them a one question survey. What was good about today? What could be improved? And whatever the feedback I get from that, I do try and then talk about it during the next session so students know that I'm taking what they're saying on board and thinking about it. One little strategy that I do want to very briefly go through is something that combines teacher-student and student-student interaction. So this is an idea I have stolen from somebody else, and if you've never seen his videos, I do recommend that you Google him because his videos are fantastic. So the idea is that you can use quizzes to engage students. So you pose a multiple choice question, and it's really a good idea at this point to pose the question so that it's something to do with something that you know is a common misconception. So it's challenging, but it's doable. Students submit their answer via real-time polling. And then what you do is you show them how the class voted, but you don't tell them what the right answer is. Then they get some thinking time, and it's best to do this in groups rather than individually. So you put students into breakout rooms to discuss the multiple choice questions. So remember, they don't know the answer yet. So the idea is that they discuss how they answered, and they try and come up with a consensus of what the correct answer should be. So if you've chosen the right kind of question, this really does generate a lot of discussion among students. So they come back to the main virtual room. You pose the multiple choice question again. You reveal how the class voted, and what should happen in theory is that you see the shift towards the right answer. So students in those breakout rooms have discussed it, and more of them now understand the reason why a particular answer is the correct answer. But in any case, you then go ahead and explain the answer. It doesn't always work. Sometimes you get a shift away from the right answer, but it's a lot of fun. Students like it, and it's something that sticks in their memory as well. So that was a whirlwind tour of all my some of my favourite things to do with students in terms of active learning. But just to sort of conclude in terms of active learning in this sort of online environment, no face-to-face, it means that we have to be even more vigilant in keeping students engaged with the material. And active learning is an obvious strategy that we can do that. I have seen some resistance from staff to doing active learning. You know, prep time is really consuming. I really like giving lectures. I enjoy lectures. I'm good at it. But this year, things are going to be different anyway. There's going to be a lot of prep work because we're not going to be giving these traditional lectures. So I like to think that active learning will feed its way in through those anyway. Sometimes I find students are a little bit reluctant to learn in this way, but I do believe it's good for students to be exposed to collaborative learning. And I make sure at the beginning of the module that I explain why I do what I do and why I'm making them do all these things. And, you know, they soon get into the swing of it. So in general, I think going online to teach is going to pose a lot of new challenges, but it is a fantastic opportunity to step away from what we've been doing for decades. And I'm really looking forward to students taking responsibility for their learning and hopefully developing independence of thought. So a couple of questions for you. Are we ever going to go back to the purely lecture plus tutorial model in higher education? Or will we actually be adopting some of these online strategies more widely, even when we can go back to face-to-face teaching? So that's it from my point of view. So you're very welcome to contact me. I've got my email on screen there. You can also contact us via the Royal Statistical Society Special Interest Group in Teaching Statistics. We have email, we have Twitter, we have a web page, and I'd also like just to plug our next event, which is the Teaching and Learning of Mathematics and Statistical Computing online, which is going to be happening later this month. So you can still submit an abstract for it. Abstract submission is still open, so please visit our website to find out more.
Hi, I'm Alison Pawston. I'm a teaching assistant in the School of Math and Stats at the University of Sheffield. So to give you a little bit of a context of the students that we teach for what I'm talking about today, we have undergraduate statistics with a fair focus on application. That's influenced both by the fact that we teach an MSc in statistics for distance learners that are often in industry, and also just because of the research focus of our staff. We have about 200 students that enter level 1. We have a core level 1 problem stats course. I'll speak about that a little bit later. And then we obviously have another core module in level 2. And then as we move towards level 3 and 4, we have these specialist courses, and they usually have about 50 to 70 students on each. Now, my subtitle here mentions something about closing a feedback loop. So what do I mean by that jargon? So I'm really talking about this process that students produce a piece of work, a tutor marks that, and they produce some sort of feedback on that work, and that gets given back to the students. So then what happens? how do the students engage with that feedback, and how do they use it to improve and grow as a learner? I would like to think that I'm not the only person here who has felt really proud of my students leaving a lecture room with this bulging folder of work where they've handed in homework, but then feel sort of deflated the next week when I leave that same room and my folder of marked homework is still quite bulging, because the students just aren't interested in receiving that feedback and actually working on going through it. And it's not just that I'm disappointed about spending time on that marking, but it's that it's obvious that this activity just isn't working for them and their studies. So what I want to focus on particularly today is this idea of the students being at the centre of that feedback process. So they're being active in it. Because as well, I'm sure I'm not alone at Sheffield in having this increasing number of students, but not necessarily an increasing number of staff. So to begin with, let's just talk briefly about why we would want to increase assessment, and in particular formative assessment. So I'm not talking about the exam at the end of a course in an exam hall, but the kinds of assessments that we have continually throughout the semester. So we have it for a number of reasons, right? From our end, we use it to check learning outcomes have been met. And there are a lot of benefits to summative assessments in this sort of classic exam hall setting, although I'd argue less so probably for the higher level graduate attributes. If you're not familiar with that kind of jargon, when I talk about sort of the course level knowledge, I'm thinking about outcomes such as carry out a Bayesian analysis for a range of statistical problems. Whereas when I talk about these sort of graduate level attributes, in particular in Sheffield, we have the description of a Sheffield graduate. And for instance, they're someone who is reflective, self-aware, and able to take ownership of their own learning. So we have this sort of two distinctions between that sort of high level and low level objectives that we want the students to meet. And that's maybe why we have assessments, but from a student's end, maybe it's more about a carrot that maintains engagement. And there's lots of evidence that tells us that more formative, rather than just that summative exam hall setting, leads to more consistent engagement. And if it's more consistent, then it's more conducive for students' learning. And for us, it allows us to flag up cases earlier that are potential progress concerns. So the key point here is that formative assessment provides that feedback that assists students in their overall learning process. So even though we know that the students will benefit from formative assessment, we do things in certain ways because we're often limited by resources, and in particular the resource of time. So there's a massive limit to the amount of instructor-student interactions that can occur. So today, I'm really going to spend my time talking through 3 specific examples of approaches that we've trialed at Sheffield to increase students' engagement with their formative assessments. And I really want to stress here that I'm not trying to get out of marking here. The idea isn't to stop offering opportunities for handwritten activities where we provide individual feedback, but how can we work out ways to have the capacity to offer more when we do have increasing student numbers and possibly a decreasing staff time? So the first example then, I'm going to be talking about, have in mind in particular that I'm talking about a level 2 core stats module. And for this, we would usually have fortnightly homework submissions, and these are essentially handwritten solutions to a number of selected exercises. So for 200 students, this gets divided by a number of staff, and the students would typically receive their work a week, possibly 2, after their submission. And that would have individual written feedback, and possibly if it was returned in a tutorial, then there would be some verbal feedback associated with that as well. So I really think one of the big barriers for students having any engagement with this kind of feedback is that things have really just moved on by this point. It's possibly 2 weeks since the student did that work. They're balancing up to 6 courses in parallel. They probably can't remember what that work was on. And it doesn't seem to really matter because the course has progressed. If they receive that work back in a tutorial session, they're likely working on a different topic at the minute. And so there just seems to be no incentive other than that final summative assessment at the end of the course, to engage with what is possibly quite difficult to read scribbles on their work. So the example that I'm talking about here then is going to be online automarked tests. And we were forced particularly into using online testing for our summative assessment last semester. But actually, we've been implementing low stakes formative online tests in a number of our pure mathematics course for a long time. And it really has a number of benefits. The automatic nature means that this disconnection between the time that the student is focused and engaged on an activity and when they actually receive the feedback on their understanding of it is just removed completely, because you can have this instant feedback if you want the test to have that. We can also have dynamic questions. So this is where I mean that the questions are slightly different between each different student on the course. And that might just be numerical information in the question, or the question might ask for something different. And the positive for us is that this discourages collusion, but it also means that there's more scope to reuse the test. So a student can do the test, they can receive their results instantly if you want them to, they can know what they know what they need to focus on, and they could redo the test if you wanted. It would be a slightly different but similar test because of that dynamic nature, and you could even have it as an opportunity for them to improve a mark if that's associated with it. Now, the key with this kind of approach is really designing the material that complements that sort of learning. You don't want it to be a strategic game for the student that sort of benefits them by cracking some formula. And it can take time to design that type of question. But you obviously don't have the marking time anymore. And you also have the benefit of cohort level statistics on performance so that you can start to tailor your feedback to the whole cohort. Now, on the question design front, I said earlier that at Sheffield we've been doing this for pure maths courses for quite a long time rather than statistics until this year. But actually stats is very well suited to this type of approach because of how naturally interpretation of results and plots fits into this subject. And therefore you can quite easily avoid this danger of sort of passive formula answering to questions. So returning to my point about this not replacing handwritten homework. In my level 2 stats course, we're now actually offering both these opportunities alongside one another. So the tests focus on the course level outcomes, and then the homework feedback is sort of more focused on these program level outcomes. So how can the students write effectively and have this good written communication of their mathematics? If students have already developed that course level knowledge by having engaged with these quick online tests where they get this automatic instant feedback, then when it comes round to them doing these handwritten assignments, then they can focus more on those other skills such as the presentation, because part of that issue with their understanding has already possibly been solved. So I think that's a real improvement there. Very briefly, I just want to point you towards the way that we implemented this for our statistics courses this year. So previously for the pure maths test, we used the AIM system, and that wouldn't really be appropriate for stats. It's just not designed for that. And alternatively, you could use whatever learning environment your institution uses. We use Blackboard, and you can set up tests within those, but they are extremely time consuming from an admin side of things. So I just want to point you towards this R package called Exams that does really help with this. You can see from the graphics here, you can have single choice, multi-choice, numeric or string answer inputs, and you can also have what they refer to as a close, which is basically just a combination of all of the above. That allows you to then have sort of an introduction to a question and then multiple subparts to it. And you can export to PDF, HTML, Blackboard or Moodle. And the important thing is that you're writing your questions in R, which is hopefully familiar to us. And so the statistics is there, be it plotting, random number generation, regression coefficients. And just 2 quick examples to give you an idea. This doesn't necessarily show the full scale of what you can do with this package, but it hopefully gives you an idea. So this is just an example from this level 2 course that's a very process-driven question. We want to test that the students can actually do the processes described here. But what we do is we have a lot of dynamic elements to this question that ensures that each student receives a very different question to their neighbour. So we have random number generation of the descriptives of these two random variables, x and y. There's a random element to the transformation that's then applied. And then the question itself is a multiple choice. So students are asked to tick all of the statements that are true. Now, there's a randomness to a random set of 4 of these that will be true. And then of those ones that are incorrect, there's a randomness associated with in what way they're incorrect. So you can see that the students get a very different question from one another. So they do, it sort of forces them into having to do that process that we want to test that they can do. And then this other example really is just to remind you that this is in R. So we can include things like plots. So we can have figures. The random number generation for the data that goes into this plot is the random element here. And you can basically include anything that you could do in an R Markdown document. So as well, you've got that easy opportunity to include LaTeX, which you can see from the previous question there. So that was very much how we can deal with these courses that have a sort of classic exam summative assessment where we want to have some formative assessments of homeworks throughout the semester. But I now want to talk about this idea of courses that have sort of more large project-based coursework elements. And traditionally, that would have a very high marking strain on the staff involved. And it also just suffers from students not engaging with the feedback on that type of work. And I think quite a big reason for that is because the pieces of work are quite standalone. And then a student perceives that then as being complete. So they hand the work in, they receive a mark on it. So they have some sort of idea of how well they've done. But in terms of going on to the next project, they don't have an understanding maybe of how that first project could affect the next one, because to them, they seem quite standalone. The module in particular that I'm thinking of here is actually a programming and problem skills module that we offer in level 1. And so very much here, each of the exercises that we get the students to do is very much a standalone application to apply the programming skills that they're learning. And so it does perpetuate a little bit this idea of the project being sort of standalone and finished. Another aspect of this is that it's more interesting for us and hopefully for the students to offer exercises that are open-ended so that they can have some creativity. So in this course, we offer sort of open-ended problems with hints on opening questions that the students might explore. But an issue with the sort of marking and feedback of that is that there's often a certain amount of grievance because students don't necessarily have an understanding of a mark scheme or an ability to self-assess and judge themselves. And so you can often get sort of appeals in terms of their marks because they don't understand why they have the mark that they've received. So a solution that we've been exploring for a number of years then at Sheffield to dealing with these sort of standalone projects is to have peer review, which you may be grumbling about, but I really think it has the potential to work very well as long as it is managed correctly. And over quite a few iterations, we've worked on how we actually implement that. So I just want to sort of give an overview of how that's implemented, and you can decide whether or not you think that would be appropriate in your own sort of peer review settings. So once students have submitted their piece of work, they're put into groups, and a group receives the same number of projects as the number within the group. We use 4 to sort of limit the work that we're actually asking the students to do on this part. So the students individually read and give a mark and feedback on all of the pieces that they've been assigned. We then hold a session where the group together discuss their individual feedback on each piece, and they agree on a collective mark together, and some collective feedback as well. And we have staff wandering around the room that drop in and out of those conversations. They also have a brief training session prior to this on how they would carry out effective peer review and marking, and they receive a mark scheme. Because it's an open-ended project, it's a very brief mark scheme. And we also want to instill this idea of the students making the decisions here. So we don't want it to be too prescriptive where they're just sort of ticking boxes. We want them to think about the feedback that they're giving. So the impressions that staff have received from this process have been really positive. The engagement in the session is very high. There are students that are really impressed by what their peers have achieved. And on sort of the opposite end of the scale, you can see that some of the very able students realise how tough some of their peers found that exercise. And it's well known that without practice, students just lack the ability to judge the value of their own work. So being shown where within the distribution of the cohort they sit can really help them understand their own feedback. And once they've understood that marking process, they understand where those grades have come from, and it has led to lower grievances and appeals on these grades. Because of the open-ended nature of these projects, there's sort of a secondary positive that came out of this, in that because the students are reading or the students' work, and because it's open-ended, they're likely not to have done the same approach as the submissions that they're reading, and they've got 4 different submissions there. So they're actually reading new maths and they're talking about it with their peers. And so they're getting some independent learning through that reading process there, which is a really nice addition. Anecdotally, I think that the students engage more with wanting to see their own feedback just because of pure curiosity. So because they've gone through that process of giving some feedback on other students, I think they then really want to see what other students have said about them. So whereas maybe they don't care what I say about them. And so I do think that increases their engagement with their own feedback there. Now, obviously the staff workload is completely removed in terms of the marking here. There would be a very cursory overview of the projects and the marks, and you replace that with this guidance and peer review session. For this particular course, we do it for quite a low stakes project. It's about 10% of a module, but it means that the marking effort can be focused on a different exercise from that course that is more sort of beneficial to place that marking effort on. So then the final example that I want to discuss is sort of a combination really of some of these approaches. So for our very large level 1 introduction to problem stats course, my colleague Jeremy Oakley has been making some big differences in the past few years to improve how the students engage with this course, and in particular the assessment on it. So because this is level 1, I want you to be thinking of sort of the content as being data handling, point estimation, significance testing sort of material. And traditionally, that sort of exploratory data analysis course, they often feature kind of unengaging toy data sets, because in an introductory course, you want to avoid this compounding confusion with nuances of messy data. But it does lead to very uninspiring data sets. And so Jeremy worked hard to identify a range of real data examples to use for all of the assessments in this course. And it ranges from sort of current topics on Brexit, local topics on Sheffield housing prices. For anyone unfamiliar, Sheffield has quite a unique pattern of one of the most affluent areas in the country, right next to one of the least. And then just some pure fun topics, such as a brain training game where the students get to actually create the data for that themselves. Now, usually if the sort of marking load of these kinds of projects on a large 200 plus level 1 course is quite high for staff, and you sort of run into these problems that I've already spoke about, where the time delay of returning that feedback to the students means that things have moved on. And so we do 2 things in this course to sort of increase that time and increase how the students interact with that feedback. So any project is a sort of a guided EDA and analysis task on a real data analysis, a real data set to make it more engaging, where at the stage of submission, the students take part in a multi-choice online test. And this is about their findings. So it's a quick checkpoint that can be used towards their project mark if you want it to. That's basically assessing whether they've interpreted things correctly. There's options here for allowing the students access to those results and whether they can actually work on their project submission iteratively alongside that test. In terms of the other part of the submission, the students learn R Markdown and Tidyverse from day one. They submit their projects in that form once they've completed the online test. And a benefit to that file format is then we can bulk compile to a stack of HTML documents to distribute among markers. And we can therefore do a quick check that the code runs and works if it's compiled. So it has that sort of quick check for the marking process of that aspect. But the important part then is that a marker goes into that sort of process of marking a submission after having both checked this online test result and that their result has compiled. And so from the online test result, they have this sort of quick prior information about the key parts of the submission to focus on. And therefore they can focus their feedback effort on things that are most important for that particular student. So the feedback can be delivered faster because if we already know about sort of the good and the bad aspects to a piece of work, we can instantly go into that marking in a quicker, effective way. There is more scope to change what happens there a little bit. You can randomize what individual students do, give them different data sets or different questions, and have an online test appropriately matched to the project that a student was assigned. And I've already said the scope for sort of allowing this sort of iterative process to whether or not the students can improve on their work. So as I wrap up, I'll just reiterate where I think the key gains to some of these ideas are. So speed of feedback is definitely critical because students will lose interest, and to actually give them some credit, they're juggling a lot of new material, and asking them to skip back and forth through content when you're learning it can be very confusing. So utilising auto marking where it's appropriate can really help. And the students just get to learn from their mistakes almost as they happen. Having some peer review in a course really allows students to realise what a good piece of work is and allows them to understand that feedback process. Remember that what constitutes a good piece of work and how to interpret mark schemes is something that we think of as being easy because we've had a lot of practice in it. So students haven't, and allowing them to have that opportunity for practice is hopefully beneficial to them. And then finally, we might sometimes just need to step back and question what benefit we're providing when we set some work. So if we're interested in how a student can present some results to a client, is it beneficial to compound that task with the possibility that they are also confused with the process of the analysis and they have incorrect results? If we can design these processes for setting up a project that efficiently allow sort of focused feedback where it's needed, then that's hopefully going to be more productive, both for us and for the students with their learning. So I've included my contact details here, but I just want to stress that the work I've discussed today isn't just myself, it's a constant effort between the whole statistics group in SOMAS at Sheffield. And as I end now, when we have time for discussion towards the end of this session, I just would be really interested to hear your thoughts on the kinds of barriers that students face with engaging in their assessments, and particularly the feedback from them, and anything that you've trialed surrounding this. We really want this session to be sort of a way to share best practices, or even practices that haven't worked very well. Thank you.
Hi, I'm Chris Holsworth. I'm a teaching fellow in statistics in the maths department at Imperial College. Today I'm going to talk about a pedagogy transformation project we undertook last summer called Learning by Discovery in Statistics. So it's a joint with my colleague Dean Bodenham in statistics, and for students Francesca, Elliot, Antonio, and Danny. So by way of introduction and some context, our undergraduate maths program is currently undergoing a curriculum review. What does that mean? It's, from my point of view, it's a review of how we teach rather than what we teach. And that led me to think about the project I'm going to talk about today. So last summer, and in other ways continuing to this summer, we worked in partnership with students to make high quality interactive resources for statistics using R Shiny. It might be that you're not familiar with R Shiny. So it's part of the R Studio offering, allows you to make interactive web apps for exploring data, conducting simulations, anything that you do in R in a scaffolded way that can be is easy to interact with even if you're not an R user. So it's a very nice way of exploring, it's a very nice way of making interactive tutorials. I'll show you some examples in just a moment. The aim of the project, really, the deeper aim as well as the practical aim of producing some resources, the aim was to increase the sense of agency in our cohort of maths undergraduates. So we find that some of the skills that you need to do statistics well aren't always best developed by the first year of the undergraduate maths degree. So in that first year, there's really a lot of focus on developing ideas of rigor and abstraction, but the learning modality, particularly for proofs, for analysis, is one of emulating a master rather than one of what you might call independent discovery. And so what we're trying to do is embed more opportunities for students to explore within the core resources of the program. It seems that statistics is quite a natural area in which to do this. That's what we set out to do. The program was supported by the Student Shapers Fund, which is a collaboration between Imperial College and the Imperial College Students' Union. So it's a program that allows us to fund students, to pay students to work over the summer to contribute resources and contribute to the design of the curriculum by giving feedback and designing things that they would like to use themselves. At the heart of the Student Shapers program are what you might call principles of equity. So I've written here partnership, inclusivity, mutuality. What we're trying to do is to value the experience of staff and students. We're trying to make sure that all students have an opportunity to contribute to the curriculum. And we're trying to offer a program that has benefits for us in terms of producing resources, but also benefits that accrue to the students too in terms of the training and cohort building as a result. So as I said, principles of equity at the heart of the Student Shapers program, and we're really encouraged to think about the power dynamics that are at play whenever students and staff work together. So you perhaps know from your own experience, it's all too common that students can end up in a position where they don't really feel comfortable challenging the approaches that we as staff are taking. And the whole impetus for curriculum review really is active learning and trying to redress that power balance. So that's something that we really tried to do in this program. Say more about how we were able to do that in just a minute. So this leads us quite naturally onto curriculum review. And really, for curriculum review, the aim is to update how we teach, although of course we've also taken the opportunity to refresh the content a little bit as well. The aims of curriculum review really is to put a lot more emphasis on active learning and maybe correspondingly reduce the emphasis on passive lecture experiences. So we're trying to make experiences that are more active for students, where they're more engaged. That means active in the sense of interacting with others, but also designing interactive resources that lend themselves to discussion and independent inquiry. We're trying to incorporate a whole range of opportunities for students to participate actively in the learning process. So paired discussions, peer assessment, discussion with GTAs and staff as much as possible too. Also, particularly in the lab sciences, but it has implications for us as well, want to encourage students to formulate independent research questions and learn by discovery and independent inquiry. Particularly at the moment, there's a lot of focus on applying technology to encourage active and inclusive learning. So to use online resources and take advantage of, for example, the ability to simulate data very easily so that students are perhaps more engaged than they might have been just seeing something on paper. So those are the aims of the curriculum review for the college. And at Imperial, we're thinking about all science subjects, engineering, medicine, but it does have implications for maths, and it helps us to think about the strengths and weaknesses of the mathematics offering. So thinking about what I've just said about curriculum review, of course, ask myself, well, what skills are we practicing most within year one maths? I think I would argue that the skills that perhaps we practice most often with students in year one maths is the idea of developing precise, watertight arguments. So a lot of first year for our maths cohort is spent learning rigorous pure mathematics, learning how to write a proof, learning how to critically engage with the proof. So there are plenty of opportunities for critical thinking within abstract settings and within quite unfamiliar abstract settings. And I think that there's plenty of opportunity too for what you might call creative problem solving within a precisely defined deductive framework. So those are the skills that I think that we really do practice. But then thinking about what we said for the curriculum review, there are some skills that I think aren't practiced so often. So formulation of research questions, that's something perhaps that doesn't occur so much as it does, for instance, in experimental sciences such as biology. So people aren't formulating hypotheses as much. I've written here independent investigation and discovery, so undirected exploration of an unfamiliar setting. That's not really something that we do so much in mathematics, although arguably it would be straightforward to do. Also mapping real-world problems into a new logical framework, so what we might call modeling. Well, that certainly should be happening in a maths curriculum, but I don't think it always has the priority that it might be accorded in other subjects. So this idea of working with messy real-world problems and working out what precise things you can say, that's not really at the forefront in a maths program in the way that it is in other degrees. Particularly for statistics, this last point, there's not really much emphasis on reasoning with uncertainty. So in our first year curriculum previously, we had a probability course, but no statistics. And it struck me that a first year statistics option would be a natural place to develop some of these skills, so to perhaps to redress the balance a little bit and encourage students to work independently on questions that involve independent discovery using data or using simulation. So I'll say something then about the project. So what did we do? We recruited 4 students to work with us for 6 weeks over last summer. Subsequent projects have also have done similar things this year, and I'm working with some students at the moment on the transition of some of my courses to a blended learning environment. So when we recruited students, we had a few principles. In particular, we were blind to academic grades. We didn't particularly want to take the best students in terms of exam marks. We were looking for students who had a particular interest in education, in design. So design of resources and design of the curriculum more broadly. We really wanted students who had an appetite for coding, and not all math students do. And of course, we wanted some people who had interest in statistics. So that's what we were looking for. We had plenty of applicants, and we were able to find some very self-motivated, independent learners who were really in a good position to produce resources that other students could use and learn from. I want to say a little bit about the day-to-day of how the project ran, because I think that the culture of the project was a real strength. So one principle was really learning by doing. So the students were intended to develop resources in R Shiny. Most of them had used R before. Not all of them had used R before as a language at all. So part of the learning curve was being introduced to that. They'd all, as part of our program, they'd all learned to code in Python and MATLAB, but first year, at least last year, didn't involve R at all. So R was new to some of the students who were just finished their first year. And none of them had used R Shiny, this framework for making web apps. They weren't particularly given formal training in how to do that. They were given access to resources that would help them to learn on the job, as it were. And everybody managed to get on board with that and do it quite well. We tried from the beginning to have what you might call a stand-up culture. So every couple of days, people would get together and informally share progress, talk about what they've been up to, what's going well, what's not going so well, but just getting comfortable with talking about what you're doing in an informal setting. So although students were encouraged to develop their own individual resources that they had ownership of, there was also a culture of beta testing and code review. So students were encouraged to make sort of preliminary ideas available and to have other people critique them and suggest other ways of doing them. And that's not just from the point of view of the coding, from the technical side, also the same thing for the pedagogy. So not just code review, but also usability review. How can you make the resources either more interactive or more accessible to different people, or more inviting to the user? And students were also given the opportunity to present a final product to peers and staff from the broader college to talk about the successes of the project. And the resources are now available certainly within the college, but I've also put links on my webpage, which I'll share. So if people want to explore the resources, they're very welcome to do so. So that's how the project ran. And I want to give you a couple of examples of the resources that the students developed. So here's one of Danny's resources. So she made a few, including this one, looking at the power of hypothesis tests. So you can see it's a nice interactive web application. It's inviting. It's easy to interact with using sliders and free entry fields for numerical values. There are points at which the student is asked questions, so it guides their curiosity. So asking what if questions, suggesting that the user change different variables and explore the consequences. The idea being that once you've started, you continue exploring and develop a better understanding. Another good design principle is to make sure the user has plenty of options, things that they can easily change. So let me just, I don't know how easy that resource is to see, so I'm just going to zoom in and show you this left-hand panel. So you can see we're testing a null hypothesis of 2 means being equal. And the sliders here allow you to vary some of the underlying parameters of your hypothesis test and immediately see the effect in a visual way. So you can, because we're doing this as a Monte Carlo simulation, there's a number of trials that you can select to look at the effect of Monte Carlo sampling noise on your conclusions. You can change the number of points that are displayed on the graph to make it easy to see. And there's independent control of things like the balance between groups. So it's quite an inviting comparison to see what happens if you have only relatively few observations from each group. And you can see what effect that has on the power of different tests, and so which ones have more power than others in different settings. Other tabs as well allow you to relax certain assumptions. So instead of working with normally distributed data, there are other data distributions as examples. And within the resource, there are suggestions for next steps if students want to work independently with data. Here's another example by Antonio for second year statistics. So Antonio made a resource about the central limit theorem. So he took a few data sets that he was familiar with, one of financial data and one some physical measurements. And he showed by resampling that the conclusions of the central limit theorem hold. And he was able to explore that in several different ways graphically. He was also able to look at some edge cases, some counterexamples. So for the edge cases, looking at quite skewed distributions where you really need a larger sample size in order for the central limit theorem to kick in. And then counterexamples too. So often in second year courses, students are presented with the Cauchy distribution out of nowhere and told that that's an example where the central limit theorem doesn't work. Antonio was able to explore that a little bit more detail by choosing a practical context where the Cauchy distribution might arise, so the ratio of two standard normals, and was able to show graphically what goes on in that setting. So again, it's an inviting, interactive resource. We have a few different tabs. It's something that students could, in principle, explore over the course of an hour, or they could dip into at their own pace. The code is available, so if students want to interact with the data itself and produce their own visualizations, they're able to do that. So it's a very flexible resource that can be used in different ways by different people. It's inviting. It uses good principles of pedagogy in showing interesting data with context, which invites students in. There are questions to encourage students to engage with it in a deeper way rather than just passively absorbing. And it explores the limits of the result that we're trying to understand. So 2 examples there of students who produced resources that are practically useful and are now embedded within the courses that I teach. To end with a couple of recommendations, I'll tell you a little bit about where we are at the moment. So as I said, we've now deployed a few of the apps from the project in teaching statistics. So I used them for the first time in my teaching last year for a second year probability course. I'm going to be developing more such apps as the autumn progresses, and be using them in the course next term, which is going to be delivered remotely for the most part. Empirically, when I started using these resources, I made it clear that they were developed by students, and got a lot of interest in the program and in the R language. So my course is the first one where students start to learn R informally. It's not a proper part of the course, but it's something that I've tried to do informal tutorials on, and they've been growing in popularity anyway. But the introduction of these resources really sparked a big peak in interest in R, which was fantastic to see. So that's a few comments about where the project is now. Couple of limitations. Well, to run the R Shiny apps, you do need an R Shiny server, so you do need something running in the background that's doing the computations, doing the simulations. That's a bit of a pain to set up for most people. We're lucky to have someone in the department who takes care of research computing who had set up the R Shiny server before this project began, so that wasn't too hard for us. Also, the students found that it took a bit of time to learn Shiny, but they overall found it was very worth doing, and because there are plenty of examples to work with, they were able to get up to speed and make things that were usable quite quickly. All the apps I've spoken about today, so there are 4 or 5 of them that I've put links to on my homepage, which you can see there. I'm afraid at the moment, outside our campus, they run very slowly. They are accessible, but they're just very slow. I'll try to improve the connection, and hopefully they'll be usable by others too. I'll finish with some thanks, so particularly to Dean Bodenham, who's my colleague in statistics, who's supervised the project with me. And thanks, of course, to the student partners who developed the resources, so Francesca, Elliot, Antonio, and Danny, who worked really hard over the summer and went from not knowing anything about R Shiny to producing fantastic resources that have really made a difference to the way that we teach at Imperial, and that's been fantastic. I'm also very grateful to the Student Shapers program, who enabled the program to take place by giving us funding. And thanks very much to you for listening.
Hi everyone, so thank you for joining this session, which I hope you found useful. I'm Eleanor Jones, I'm a Senior Teaching Fellow in Statistical Science at University College London.
Hi everyone, I'm Alison Paulston, I'm a Teaching Associate in the School of Maths and Stats at the University of Sheffield.
Hi, I'm Chris Holsworth, Senior Teacher Fellow in Statistics at Imperial College London.
So thank you very much for the questions that have come through. So I'm very happy to answer the ones that are relevant to my talk. So the first one that came through was about student names appearing in the forum. So the way that I set up my forums is that the students can post anonymously if they wish. So if I, for example, do my sort of cheeky little thing of going in and posting a question to get the ball rolling, I also post anonymously. So all that appears is anonymous user. So students are not aware that it's me, and they're not aware of the gender of the person posting the question. That does have a bit of a downside, because students can post anonymously. What you tend to find is that students, rather than thinking about a question themselves, will just fire it into the forum. But if it's student-led, then what tends to happen is those questions don't get answered, and I won't answer those either. If it's not student-led and that I'm leading the forum, I tend to delay my answers so they know it's worth them thinking about a question before they actually go ahead and post it in there.
Can I ask a question to follow up, Eleanor?
Sure, go for it, Chris.
So because this is something that we're thinking about quite a lot, so with lots of things moving online, did you announce in advance a policy on not replying to a question for a period of time, or did you just allow a culture to develop of that you leave it, say, a day or something, or?
So for my courses, I usually tell students that a response will be there within a certain number of days, and I will say some number of days. So to set up that, so something along the lines of 3 working days, so they know that it's worth them thinking about it rather than just firing it off into the forum first of all. And that tends to work quite well. But what I find that is students, because they're allowed to answer each other, and I always encourage that, whether it's a forum that is specifically student-led or not, they tend to answer each other much quicker anyway. So I think that's a really good thing.
Do you have to put much effort into moderation of student responses? So is there any way, so do you ever have to either remove a student response or reply to it to say, well, actually, that's not quite, so how do you deal with, because I think that dealing with something that we've thought about quite a lot recently, how do you deal with something like that tactfully? Because a student, someone who's responded but is just wrong, then there's obviously a self-esteem hit when the lecturer comes in and says.
Occasionally happens, but I tend to find that the students who answer are very confident in their answers, and they tend not to do so if they're not quite sure. Occasionally, the answer won't be quite right, but then I will intervene. I will let them know that the answer is really good, but just to add a little bit of clarification, then I add a little bit more at the end. But I don't want to discourage anybody, but obviously we need to be very careful in not allowing misconceptions to be posted on these forums. But no, I generally find that it's the stronger students, and it's good for them to actually think about how they go about explaining an answer to other students. I think we've got some other questions that we can briefly, if we're allowed, just go through. So number of students in breakout rooms, I usually do 4 or 5 students in a breakout room. Less than that, and I feel if anybody's not wanting to actually take part, then the group gets a bit small. Any more than that, and some students are a little bit hesitant in taking part. Some recommendations for websites or videos for demonstrations. I can really recommend websites developed by Brown University, Seeing Theory. That one's fantastic. Very creative, very arty. So students really like that. Dealing with students, especially in team exercises that are not engaging, it does happen every time. I spend a lot of time explaining to students why I get them to do this. And I often find that doing very small activities, non-threatening activities, when they first go into groups, give them something really simple to do, something that they cannot possibly be frightened of. And that tends to get them talking. So a little bit of an icebreaker is always really good. I don't know whether Alison or Chris has anything more to say on those sorts of questions.
I've started, previously I used to spend quite a long time sort of editing myself in recordings and things like that, and I've stopped doing that now because I kind of want the students to see all the silly mistakes that I make and things, so that it creates that environment that's not so polished and scary, and then maybe they'll be okay with it.
Yeah, I quite agree that perfectionism is I think it's a bit of a sin for us, but it's certainly something that the students can easily take our bad habits on. I'm in the process of recording lots of videos at the moment, and like you, left to my own devices, I spent a lot of time polishing, but I've slowly learned that I think I'm trying. No, there are some bloopers get removed, but I think you're right that there's a danger of having perfect and polished experiences that can be either hard to live up to or just simply not engaging because they've been edited so much. So completely agree with that. Mind at the moment.
I completely agree with that as well. I now leave in some bloopers just to show students I'm only human after all. But I think we have now officially run out of time. But thank you very, very much for joining the session. Please do keep in touch with us. And please do explore our webpage for the special interest group in teaching statistics. We've got some events coming up, which we'd love you to come along to. Thank you very much.
Thank you. Bye-bye.